Okay, so today we are going to learn about segments and congruence. All right, so when you have a number line, a coordinate is a number that corresponds to a point. So we would say that -2 is the coordinate of A. Or we could also say 2 is the coordinate of D. So the coordinate is a number that's going to correspond to a point. Okay, so basic number line, and we can assign letters to the points. Okay, we can also find distance by subtracting coordinates. Now, actually, when we are trying to find the distance from a number line, we could just count the spaces. It's pretty basic. We don't need the distance formula, which you probably used last year, and we're going to learn in the next lesson. However, when it's on a number line, you could just count how many spaces or gaps are in between the two numbers. So for example, if I wanted to know the distance between point A and point D, I could just count the jumps. And I could say that there's 1, 2, 3, 4 jumps. And that's the distance between point A and point D. Or you can find it by subtracting the coordinates. You're always going to subtract big minus little. So notice here, I took the big number 2, I subtracted, and then the number was -2. So then when you do 2 minus -2, it really turns into 2 plus 2, which is 4. Okay? Everybody understand how to find the distance when your coordinates are just on a number line? It's not in the full coordinate plane yet. All right, let's go on. All right, this year we are going to be learning a lot of postulates. And a postulate is just a statement or a rule accepted without proof. It may also be called an axiom. However, our textbook is going to call them postulates. So it's going to be a rule that you're going to memorize, and some of these postulates you're going to use as reasoning for your proofs. The first postulate we are going to learn about is called the ruler postulate. And the ruler postulate states that the points on a line can be matched 1 to 1 with the real numbers. And then it says, once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of their coordinates. And I'm going to explain what that means momentarily here while you guys finish writing. Now, what that highlighted sentence in blue what it really means is when I showed you the example above, I told you do the big number minus the little number to get the distance. However, if you find the absolute value of your answer, you can do little minus big. So technically, if you do little number minus the smaller number, or sorry, minus big, so little minus big, and find the absolute value of the answer, it's going to be the same answer as if you did big minus little. So for example, if I wanted to find the distance between point E and point A, or A to E, I can either do big minus little, and then I would get 4, or I could do little minus big, but after I do the problem, I need to find the absolute value. So what is -1 minus 3? -4. But then when I find the absolute value of -4, what do you get? 4. So just remember to find the distance when your numbers are on a number line. You can either do big minus little, and that's going to go right to the answer, or little minus big, but then just take the absolute value of your answer. Any questions on that? Now, just like I showed you before, we don't necessarily have to do the subtraction when it's on a number line. We can just count the spaces. So let's count how many jumps it takes me to go from A to E. So if I count the jumps, it goes 1, 2, 3, 4 jumps, and it gets me to point E. So that distance is 4. Okay, counting the little spaces like that will only work when your line is either horizontal or vertical. If it's diagonal, we're going to need to either use Pythagorean theorem, which you learned last year, and make it into a triangle, or use the distance formula. Any questions on this ruler postulate? Just basically saying, imagine a ruler. What do you see on a ruler? Numbers, right, with little lines. So all this is imagine a ruler, and on your ruler it's spaced out with the numbers. All right, let's go on to the next one. On this one, right here.
No, down.
Down one. Now we're going to talk about adding segment lengths. We are going to be using adding segment lengths quite a bit. Okay, you're going to use the segment addition postulate throughout your proofs coming up. So what adding segment lengths says is when you have 3 points that are collinear, you can say that one point is between the other 2. Now in order to use the addition segment postulate, this word between is going to be very important to us. We need to know that one of the points is in there, in between them. So notice it says point B is between points A and C. It doesn't say it's halfway in between or in the middle. It just says it's between. So it's somewhere on that line in between A and C. Now notice on the other picture, point E is not between D and F. It's not on the line. Yes?
Point E isn't collinear, right?
Correct. E is not collinear. It's not on the line. So it would be non-collinear. Any questions about adding segment lengths here. All right, let's go on. Right there? Okay, you're welcome. Okay, back to the addition. So here is postulate number 2. Number 1 was the ruler postulate. Number 2 is the segment addition postulate. And again, the word between must be somewhere stated in the problem. So it says if B is between A and C, then AB plus BC equals AC. So because it has the word between, I know that point B is somewhere in between A and C. Again, it doesn't have to be equally spaced, it's just somewhere in there. So what they're stating is that this piece of AB plus the piece of BC, so AB plus BC equals the entire line AC. And in your homework, you're going to actually have numbers. And you're going to have to show this. Yes?
Can you go back up to postulate?
Yes. So, for example, let me put in some numbers here. Let me erase. So, let's say I told you, and I wanted to find a length. So what if I told you that AB was 3 and BC was 2? What is the length of AC? 5. Now, we can also work backwards. So what if I told you, and I can draw, let me draw a line here. So what if I told you AC equals 10 and AB equals 6. This is AB. How could you find out what BC is?
You can do 10 minus 6.
Perfect. So you would take your addition, your segment addition postulate, and you could say that 6 plus BC should equal 10, which is AC. And then we would apply our algebra. And we would do 10 minus 6 to get 4. Yes?
So all you're going to do is add AB and BC to get AC?
Yes. Good so far? All right, let's go on to the next slide. Anybody still need this one? You need it? Okay, I'll wait. Okay. Anyone else need it still? All right. Any questions on this? Okay, let's move to the next slide. Okay, so here's some examples. Now, the one I gave you was really basic. Now, they may end up giving you just numbers, but they also may give you expressions for the value of that segment. So let's go ahead and draw a picture. Again, notice we've got the word between. So we're good to go on this segment addition postulate. So I'm going to go ahead and I'm going to draw my line, and I'm going to put point J. Actually, I'm going to put point I first because J is in between. So I'm going to put point I, and then I'm going to put point J, and then I'm going to put point K. Because it stated that J was in between I and K. So now what I'm going to do here is I'm going to label what's given to me in the problem. So I'm going to label that IJ is 2x. So from here to here is 2x. And JK is 4x minus 6. And then it's telling me that the whole line from I to K is 30. So here we go with our algebra. What do you think we need to do to find the value of x?
Second equation is 2x plus 4x minus 6 equals 30.
Beautiful. So you are going to take each piece of the segment. First segment, IJ, which was 2x. And then we're going to take segment JK, which is 4x minus 6. We're going to add those pieces together. And we know the total segment is 30. Now I have to begin my algebra of combining like terms. So what can I group together? 2x and?
4x.
And what do you get?
6x.
Okay, so I get 6x minus 6, because I've grouped these two, equals 30. I now have a two-step. I need two inverse operations to solve this. Yes?
Well, you have to subtract 6 to the other side.
Beautiful. I need to move the 6 first. So I'm going to add 6 to both sides. I get 6x equals 36. Now what do I do? Divide by 6. And x equals?
6x.
Beautiful. All right. So the value of x is x equals 6. How do you think I'm going to find the value of ij?
By plugging in 6 for x.
Good. Into which expression? The 2x or the 4x minus 6?
2x when you're finding ij.
Okay. So to find ij, I'm going to plug it into 2x. So I'm going to do 2 times 6. And what do you get? 12. Okay. How can I find jk?
By plugging 2x into 4x minus 6.
What am I going to plug into 4x minus 6?
Oh yeah, you plug in 6.
Good. I'm going to plug in 6. Wonderful. So then I'm going to do 4 times 6 first. What do I get? 24. And then 24 minus 6. And that's your answer. So here we go. We're already pulling in all of that Algebra 1 that you learned a year ago. So we need to start remembering. Now I know you did a lot of this, so this was the beginning of the year, but it's going to all come back, right? Okay. Any questions on how we're going to be using this segment addition postulate? Okay, so it'll help us find the different pieces by either adding 2 pieces to make one big one, or if they give us the big amount and we wanted to find a little piece, we would subtract. Anybody still need it? We're good? All right. Okay, next we're going to talk about congruent. And we will talk about shapes being congruent quite a bit. So congruent are 2 objects that have the same size and same shape. Okay? Congruent segments are line segments with the same length. So it's sort of like being equal, but a lot of times when they talk about congruent, we may not have a number. Like for example, we could say segment AB is congruent to CD without knowing the value of it. We don't need to know that maybe one of them's 4 and the other one's 4. So the symbol for congruent is an equal sign, and then it has a little wave on top. Or maybe like in Spanish, like the little ñ symbol. Okay, so it's an equal sign with a little wave on top. Okay, that's the congruent symbol. So we could say segment AB, and again, they're drawing a picture of a segment on top, is congruent to segment CD. Because they're the same size and the same shape. Yes?
Can you do an example of the shape?
With a shape, sure.
Can you please send Alexa Regalado to Student Services with her iPad?
Yes. Go ahead and take it just in case. And we only have one more slide, so I'm going to try to post the video today.
Thank you.
So just look for an announcement with the link to the YouTube. Okay. So you wanted to see an example with shapes. Okay. Question?
Is there a video?
No, just go. Because they called for you.
Is there a video already for the first one?
There is a video, but I haven't given you guys the link. So I'm going to try and do that and see if you guys can get to it. Maybe you guys will be my guinea pigs and I'll tell you the link. You guys can try it. Okay. All right. She wanted an example of shapes. All right. So congruent shapes might have this. And we're going to start seeing, all right, notice these little red marks here on my line segments before I go on. These little marks, these little red marks, are called tick marks, and or also congruency marks. So whenever you see the same type of marking on either a segment or an angle, that's showing you that they're congruent. Now, I'm just drawing this by hand, or I wonder if I could put, let's try. I'm just going to draw it by hand. So let's say I have a triangle and another one. So even though they don't look exactly perfect,
Make strange lines.
okay, let me try that. I could do that in this, but I know in Notability I can. I don't know about this because I'm taping this. Let me try. Because it works very similar to Notability. Let's try it. So I know if I hold down my cursor, no, it doesn't let me. Okay, what I could do, I'll do this. Can I
What about
cut?
the shape?
I was looking at that, but I didn't see.
Can you maybe copy it?
That's what I was going to do, see if there are scissors. Let me see if I can do that. No, all right. I'm going to have to play with this app a little bit more. If it's Notability, I could do it real quick. So let's just, what I'm going to do is I'm just going to put tick marks. All right, so I have 2 triangles here. We're going to say that these are congruent. And the way that we can tell that they're congruent is I'm going to add markings. And let's pretend like they're equilateral triangles. And they're going to have all the same sides, and they're going to also have congruent angles. So when you have congruent figures, they're going to have exactly the same markings. All right? If the triangles, say, were isosceles, let's see if I can draw. It's not gonna let me move. So let's say I drew 2 triangles here. These would have the same size, so the same markings, but the base could be different. So we're going to be viewing quite a few triangles, and we're going to have to prove them congruent. And we're going to learn a lot of postulates. So for now, just realize that if they have the same congruency tick marks or congruency markings, then they're congruent figures. Yes?
What about like instead of each separate side being congruent, what about like as a whole shape? Can it be congruent to something else?
It would have to be exactly the same shape and same size. So it would have to be 2 triangles, 2 rectangles.
But for this one, you're only comparing the sides.
You can also do angles. In order for a figure to be congruent, sides and angles must be congruent. Everything. Every piece must match. Okay, and what they're gonna do is, sometimes, you know, they might be turned sideways. So the key thing to look at are those congruency marks. And then you'll know exactly what matches with what. Okay, now, in the next slide, no. Geometry, we do these questions that are, the answers will be sometimes, always, and never. And sometimes they can be tricky. So in order for the answer to be sometimes, it could happen some of the time, or it can happen maybe not all the time. But when it's always, it always has to be true or always happen. If the answer is never, it's never going to happen. So, number one, the length of a segment is negative, right here. Never. Okay, distance is never a negative number. So if I'm measuring something, I'm not going to measure something and say, the length of that wall is negative 100 feet. The length is never, ever going to be negative. All right, next one. If point S is between R and B, then S always lies on RB because of my word between. Okay, so if the word between wasn't there, it wouldn't be always. It could be sometimes. So this one is always. And the last one, a coordinate can blank be paired with a point on a number line. Always. It's our ruler postulate. So you might have thought I tried to do all three, but it's always.
Oh, because it always matches with one?
Yes, it always matches with a value, a number. So always. And that is the lesson. Any questions on the ruler postulate or the segment addition postulate or the congruencies? Okay, so we have quite a bit of time. Yes? No? Maybe not.
How much minutes?
I think, when do we leave? 11:35?
11:33.
Oh, never mind. All right, have a good day. Your homework is practice B. I will try to post these videos, and I will post the link maybe in announcements or check the homepage.